Hello, my dear student. I'm Mr. Ktwala from Educare TZ. I will be with you in physics for Form 5. Today, my dear student, we are going to proceed with our discussion about the topic of rotation of a rigged boat. For our subtopic of the torque of rotating a rigged boat. This is our subtopic that we are going to proceed in our discussion here. Before we proceed with our discussion, now we were supposed to remember where we ended on the last session. On the last session, my dear student, we tried to see the comparison about the linear acceleration. The examples are related with the linear acceleration. This is what we tried to see on the last discussion. We said that if we have several rigged boats and try to release at the same point at any time t. Now we observe that among of them, there are some of the rigged body could reach at the bottom faster than at the other. That is what we try to see, and we said that we try to see the examples about the sphere and also the solid cylinder, kwamba tunapokuwa na solid cylinder na cylinder tukidisplace at the same point kwa pamoja tukirelease, kinachotokea ni nini? Yule sphere atafika chini kwa haraka zaidi ukilinganisha na yule cylinder, kwa sababu sphere anakuwa ana linear, it means kwamba anakuwa ana linear acceleration ambayo ni kubwa kuliko ile ya cylinder, kuliko ile ya diski. Kwa haya maswali yanakujaga ni mengi sana yanayohusiana na kumeki comparison, kudetermine the speed of the rigged body when they are being released together at the top of the inclined plane. So for our today discussion here, let us see another example, or example number 18 here for our fourth topic, my dear students. And our example is divided into two Romans. We have Roman A and also we have Roman B. So on Roman A here, our example say that a solid cylinder of mass M is placed on a raft of inclined plane with inclination of angle theta. We have the solid cylinder, and that is solid cylinder, my dear student, they are being placed. First of all, it contains the mass M and also the radius R. They are being placed on a raft of inclined plane. They are being placed, or they are being allocated on the inclined plane with an inclination angle theta, katika inclination ya angle theta to the horizontal one, as we tried that we have the inclined plane and that inclined plane contain 2 points, the point that indicate the top and also the point that indicate at the bottom. Now we take that cylinder which have the mass M and also the radius N, and try to displace it at the top. It means on the left inclined plane, but the inclined plane tried to make it the angle theta, which the angle which is called the angle theta. This is formed between that inclined plane, but the axis of rotation and also the horizontal axis, as it is shown on our figure number 30 for our fourth topic here. So show that the minimum frictional force required for the cylinder to run without slapping is this one. The thing that we are supposed to do here is to go and show that the friction force required for the cylinder to roll without slapping ilikuwa ni sawa na 1/3 mg sin theta, and that minimum coefficient of C is equal to 1/3 tan theta. This is what we are supposed to go and show on our question here. our question need us to go and show that the minimum frictional force must be equals to the minimum frictional force must be equals to 1 over 3 mg cosine theta, and also the coefficient of friction. This is the coefficient of friction is equal to 1 over 3. Then we times it by the tan theta. This is the regardless of our question here. So our figure that is we tried to see on our statement for our example here is this one. Now we have this figure that represents the solid cylinder rolling on a rough inclined plane. Kwa tuna solid cylinder ambayo ina roll on the rough of the inclined plane. This is a figure explaining. If we observe very carefully our figure here, my dear student, we see this is the structure of the inclined plane. But on the inclined plane, we have this solid cylinder. And this solid cylinder trying to roll on this inclined plane. But this inclined plane, it have the height. That height is allocated from this horizontal axis up to the point up to the top of the inclined plane. Kwa height yake tumeshapewa imebidi represented by the symbol h. And also, my lovely student, here we have the angle of inclination. This is the angle formed between this line and also this horizontal axis that we have on our question here. Also, we have our rigged body. Firstly, I was at the top, but it tried to be displaced, or it tried to be released, it tried to allow on any inclined plane. But the angle that is formed between the axis of rotation and also the horizontal axis must be equals with this angle. The angle that could be formed between the vertical axis and also this axis. It means the downward force as we try to observe here. Kwa hiyo angle yetu tunayo pale. Also, we have the normal reaction Rn that represent the normal reaction here. This is labeled the force that act upward on an object which is either on the table or which is either on the inclined plane. This is the concept that we tried to see when we was on form 2, on form 3. So the vertical force here will be the vertical forces we divide the if we dissolve this vertical force must be equals to mg sin theta, kwa sababu tunaipata hii mg sin theta kama huyu hapa ni hypotenuse na huyu hapa kama huyu hapa ni opposite na huyu hapa ni hypotenuse, tunaweza tukapata huyu horizontal force ambayo ni sawa na opposite atakuwa ni sawa na mg sin theta from sotoka hii. While this vertical forces here, if we resolve by considering the Pythagoras theory or by considering the sotoka here, this will be the adjacent. The vertical force must be equals to the adjacent, and if we dissolve, we could obtain that this vertical forces which is equal to the adjacent must be equal to mg cosine theta, as we try to see. But if this is solid sphere trying to roll on the inclined plane, there are some forces you could exert. This force is called the friction force. As we try to see, this is the friction force that oppose the rolling of this solid cylinder on an inclined plane. So after this one, let us see the solution of this question. Because we have been asked to prove that the minimum frictional force is equal to 1 over 3 mg sin theta, while the coefficient of the friction equals to 1 over 3 mg, it means 1 over 3 tan theta here. So there's two things that we are supposed to consider when we prove this formula, when we prove this minimum force. The first one is we are supposed to recall we are supposed to recall, my dear student, we are supposed to recall the translational motion and also the rotational motion. As we have tried to say on the previous period, on the previous lectures, we said that when the body rolling on the inclined plane, it gives us two motion. It can obey only two motion. There is either the translational motion or there is either the rotational motion. This is what it can obey when it is trying to roll on the inclined plane.